Hi, welcome to flexiWAN Academy. In today's lesson, we are talking about taking flexiWAN to production. So this is our 11th lesson, and the goal is to basically summarize everything that we have had webinar or lessons about. So in this lesson, you will learn how to plan your production deployment using flexiWAN. This lesson will utilize many of the previously covered topics, but now we want to apply them to the real-life production environment. So we are going to use actually a combination of devices, both for both VPSs, which will serve as our data centers and act as a few data branches, to physical devices which have LTE and Wi-Fi and so on. So the goal here is actually to use to show real life production deployment. So covering planning and deployment, deploying advanced flexiWAN environment, which is basically ready for production and utilizing multiple device types, tunnel topologies, pairing, path labels, path selection, firewall policies, and if we find time, we'll also get a chance to put some pairing to ability to connect to the third-party IP devices using IPsec, and finally finish all with remote VPN for road warriors. So let's get started. Because this is going to be a bit different webinar. All of this is actually happening in real time. I'm recording and building everything from scratch. So because of that, I wanted to cover a little bit of, first, to show a diagram, basically to talk a little bit about what our goal is. And there's a simple version of a simple diagram and a little bit more advanced diagram that I plan to display. So, but in a nutshell, this is it. What we're going to do today is we're going to build 2 data center devices. We're running flexiWAN, and they will be in the same data center, and they will be used for remote branches to access resources behind these data centers, and also to route all data, all the company data. Some will have company data, others will have all traffic through the data centers. And the goal is actually for each branch to connect to both of these data centers at the same time, which will show the power of flexiWAN in a way to how to basically connect, how to quickly and easily connect all of these sites using multiple topologies. For example, each branch will be connected to data center using in hub and spoke. So each of these branches will be connected to both data centers in hub and spoke, and also both data centers will be interconnected between them. So in case DC1 goes down, the branch will still be able to access DC2 flexiWAN, and because it will have 2 tunnels, and both tunnels will be for failover using path labels, which we'll talk about a little bit more later. But that's not enough. What we also plan is to have all these branches in full mesh topology. So this is just as an added precaution for a backup in case one branch has some upstream routing issues but can access other branch. It should be able to access the resources from DC1 and DC2 through branch 2, assuming the branch 2 is connected. And because the assumption is this, basically, with SD-WAN we make things very easy to connect, but with multiple sites, you don't necessarily have same ISPs on each site. So one branch will have dual WAN, all other branches will have single WAN, and all of these branches will have different internet providers, should in theory in production have different internet providers, and different internet providers always have different configuration types, and it's completely different, even sometimes upstream routes, they even use completely different upstreams. So, we've found that that it's not, even though it's easy for flexiWAN to connect tunnels, if there is no an actual route or a way for branch 1 to reach DC1 because of some internet outage in upstream through its own ISP, it may be able to connect to the closest branch, and then closest branch, which is a secondary different ISP, will be able to connect DC1 and DC2, which in turn will also be able to communicate with branch 1. So this is an example of a diagram of a very single device branch. Single branch will have ISP1, ISP2. These are actually going to be two internet connections. One will be the wired one, and the other will be the LTE. And both actually will connect to these. And actually, I think I made a mistake in this diagram. I just realized. So what basically is going to happen is branch 1 will have a connection from both LTE and from both LTE and wired to DC1 and also to DC2. But we'll talk about that a bit later. So yeah, that's as on a single branch. So each branch will connect to both DCs in hub and spoke topology, and then it will connect to other branches. So how this will end up looking in a bit more complex way is that, it's going to be full mesh between these branches, and each of the branches should be able to connect to each of the DCs. And yeah, that's about it. So let's get started. I hope we'll have time to cover everything. This may be a longer webinar, lesson than usual. As you can see that we really do have a completely clean slate here. So we are starting from scratch. And the first thing that we're going to do is, let me bring the diagram a little bit back, is that we're going to build DCs. So the assumption is this: data center, better uptime, higher availability, because your flexiWAN is running in a data center. Right now, we're going to install and build 2 data center devices that are running in data center. And for the purpose of this, production level demonstration, we're going to use a headset VPS, which provides really rock solid capabilities for both production and also testing. And also it's very easy to deploy flexiWAN there. And right now I have SSH to both of these DCs. And I wanted to do a demonstration on how to quickly get flexiWAN working using terminal only command line deployment. So here, the first thing that you want to do is, because this is a VPS and they're using, we deployed flexiWAN using Ubuntu 18.04 long-term support version, which we, by the way, we're going to be updating also to the latest LTS very soon. But current LTS 18.04 is still fully supported by Ubuntu and Canonical. So this is a vanilla Ubuntu. So in order to install flexiWAN, and by the way, we already covered this in the first webinar, but we'll touch many all of the previous lessons just to summarize it all together. So the first step is we want to install flexiWAN. In order to install it, we want to add the webinar. We want not webinar. Sorry, we want to add it. We want to go here basically to manual installation and documentation, and we want to add the repository. So you just want to copy this repository link and paste it. And in a few moments, it will add the repository and fetch apt get update. And now all you have to do is literally just copy the command above. And in a few moments, flexiWAN will be installed. So for those who have watched all previous lessons, you know that the first step is to really just follow the on-screen instructions, which is the run system checker. So system checker will run, and in most cases, everything will pass. And you can configure system silently or interactively. I personally like to configure it interactively because I want to enable power saving feature, for example. And this is something that you may not want, but I enable it just for the purpose of the demo. on the main core. So the main core is not using 10% CPU all the time, but on the second DC will not do it. We'll use a silent way to run system checker. The purpose of system checker is basically to prepare the machine, prepare the host operating system for flexiWAN operation, and to make sure that everything is working fine. So now that this is ready, we go back to flexiManage, and we go under inventory and tokens. And from tokens, I already pre-created in advance a token for DC1. So the idea behind tokens is the token connects your device to your flexiManage account. So you can use a single token for all devices, or you can use multiple tokens, each token for each device. That doesn't matter. For added security, you want to have probably DC tokens used to be one, and then the other you want to use basically a single token for data center devices and a single token or individual tokens for all branches. In this case, I'll simplify. Let's call it just DCs, and we'll use this token. So just a copy. You go back here, and you insert token into etc flexiWAN agent token, and you just save. You use nano or VI, whatever, and that's it. The token is added, and in a few moments, the device should be pending here and waiting to be approved. So I'm not going to configure it yet, but let's call this one DC01 and primary DC site, and click update device. So this device will run a few more things in the background, connect in a few moments, but let's prepare the second DC. Same thing applies. Go back to manual installation because we're using a VPS here, and I want to paste the repository, and afterwards we are installing flexiWAN. I already installed it in this case. Okay, it doesn't matter. So let's run system checker. This time we'll configure the system silently, and you can even check afterwards the 0. So I did number 2 first, and then I did number 1 to check that everything is working, that everything is passed. So that's it. We exit with 0. It's always important to exit system checker with 0 because it will actually restart the service. Don't do Control-C. And let's get back to the flexiManage. Let's copy this token again, and let's add the token. By the way, we are now demonstrating how to do command line deployment and installation of flexiWAN, which are for the data centers. But we're going to do for branches is we're going to use the web UI for an example, which each flexiWAN has also enabled by default and accessible. So here we have DC2, DC. So secondary data center size. I call the first one like this, but you get the point. DC2. That's it. So we now have 2 sites, and let's configure and get them running. But we're not going to do any connectivity yet. So let's configure interfaces. The first thing that you want to do, you want to approve device, and then you want to assign the interfaces. In this case, we're just, everything is pre-configured, and all we want to do is click update device. I may have actually did a small thing here. So with HeadSnap, by default, they use their own system to deploy images, and they don't use NetPlan to configure interfaces. So let's check. Yeah, so here, the original NetPlan file actually does not follow the interface naming. It does not have ETH0, so 63 and 63. Instead, it has just this default file, and this will not work with flexiWAN. So all you have to do is you have to rename this to ETH0, and you can actually check with netplan apply. Yeah, it's working now. So because otherwise flexiWAN will not work in this case, and because we rely on netplan. If the netplan is not correctly assigned, using has interface names that are not in use, flexiWAN will fail in this case. But now it's going to be okay. So DC1 is ready. Whoops. So DC1 is ready, and we can start it. Actually, I'm not going to start. Let's go to DC2. Let's assign it as well. And click update. So you may have noticed that I'm configuring all of this via SSH, which means that the moment I start flexiWAN will run and it will block all incoming connections, because by default we allow all outgoing and block all incoming traffic. So what will happen to SSH? It will freeze. So just let's add a rule that allows SSH to this FlexiEdge device. So this means this means WAN. I'll leave the source for any at the moment, but of course you can use a custom IP to limit access to only custom IPs or custom ranges, which can later be defined in traffic and app identifications. So I click add rule, click update, and so you'll notice actually that this is a device specific rule. Later we'll cover policy for security policies, which will have multiple rules, and then we will install them on all branches. Just to demonstrate, So here we have the first device is running, and let's repeat the same process for the second device. And right. So now we already still have even access. We have two DCs ready. So these two DCs are ready for action and actually to start to build the network around them. So here the idea is that we will connect all branches to DCs and we have two DCs for failover, and these DCs are connected between them. So the branches will use the data centers to actually use internet. They will use data centers as internet breakup. So they will route all traffic through the tunnels connected to DCs, and then they will use them. The devices will use FlexiEdge sites will use data centers as an internet breakout, which is it offers more control, and we have this is a common security practice and common way to deploy flexiWAN. Of course, you don't have to use it like this. You can just deploy using some branches, and I'll show an example. Some branches can just have you access resources on the other side, but use internet breakout for internet. That works too. And the assumption is actually here that also behind data centers, there's additional infrastructure like accounting servers and everything, and or that you have other sites that have physical infrastructure like accounting servers or any kind of infrastructure, and they are going to be connected to these. They're going to be behind data centers, and in fact, if there's time, we'll actually configure peer, which will have some resources behind them and behind it, so the clients will be able to reach them. Okay, so just to refresh here, we have both of these sites working. At least I hope so. I may have lost control of the second one, and this is likely because of the netplan thing that I did. But okay, it doesn't matter. Let's move forward. In this case, I do have the screen console to the secondary data center, so it's possible that I quickly double check what's going on. So it's 2. Yeah, so you may actually see a live troubleshooting scenario. So we have console here of the DC2, and let's do tail. So Oh, 1 second. Oh, no, I'm not using the correct console. This is why I got confused. Yeah, this is the correct console. So great, you get to see how we troubleshoot live some connectivity issues. So if this device is probably not connected. It's not connected for some reason. We installed flexiWAN on it, but I believe the issue is here with the net plan. And here we have agent log. And this device cannot connect for some reason. And if I do that, let's see. Oh, it actually has connectivity. It has an IP. So we actually have the original net plan, which is going to be ETH0. Okay, let's check the other one. So actually, things looks to be fine. It seems to be working, but for some reason the device has no access to internet. Maybe it's something related. So what we'll do is FW kill. This is the device is not connected for some reason. We can do FW kill. It will disable all communication and disable all flexiWAN services and communications, and we will restart the router. And what we're doing now is going to log again to see what's going on. And let's see, maybe this was just a glitch. There is some communication issue, temporary name. Maybe it's DNS issue. Okay, so in this case, let's do this. FW kill. And then what we'll do is we'll reset the configuration. Just with -S, which just restarts the configuration, and we'll start the router. And now for a few moments, it will connect back to UI. Here we have it. And it's not running, so it's now syncing because we reset it. It's syncing, but let's double check to see what we did. Yes. So the issue here is that for some reason it switched to static on the WAN, and that's not good because this is a VPS provider. So you always make sure that WAN is on the HCP. At least I hope this is the case. Let's see. I think the net plan was fixed, so now it's gonna reconfigure everything. Now we're waiting for the log to update again. Okay, so let's try now. Starting to run the device. Let's see, because the DC1, DC1 has the HCP on WAN, and it's important to have. It's not going to work with Headstart and most VPS providers because they receive an IP via the VPS is receiving IP, but from their own infrastructure. So yeah, now okay, good. So now we're connected. So you have witnessed the live troubleshooting session using Headstart. So yeah, always make sure that WAN is static. So we have now two DCs, so DC1 and DC2. Nothing is yet connected, but we don't want to connect anything. Instead, what we'll do is we'll switch to, I believe, so the next step is to start building physical branches. So we built the data center branches and explained how they work, the purpose of them. So now we'll build LTE branches. Physical branches, and the first branch will be the actual physical device. And for this purpose, we're actually using one of the hardware from our hardware partners, Advantech, and this is the device that we're using, 11112 VC or 1112 VC. Yeah, this device, and we have other hardware partners that you can check out. Basically, we're building here flexiWAN from scratch, but what's possible is on a larger scale is to organize, mass deployment thanks to the tokens that we use and thanks to the fact that we use Sport Cloud in it. So you can have, zero touch deployment where you can have, hundreds, thousands of devices, shipped on each site, on all of the sites, and on first boot, they will show up in flexiManage and waiting for approval and to complete the configuration. So, that's the benefit of using our hardware partners. Especially if you have a large scale deployment, they can even pre-configure devices with the token for you. So moving forward, we have 2 sites, 2 data centers that are ready, and now we're moving to the branches. The branches will build a couple of branch sites, and then we'll use them to connect to all the resources that we have. So for this purpose, we have a device here, and this is a device that I just showed, Advantech device. And the procedure is the same. The only thing is that we're going to use local web UI to do initial configuration, which is basically follow the identical steps from the terminal deployment. First step is run system checker. Go here, and it's going to say you have to run system checker, and usually it's going to say it's not met, UUID and core dump settings are not passed. You just have to click auto fix, and that's it. Few moments, all system requirements are now met, you're good to go. Next up is interfaces. So I wanted to talk a little bit about this page. The interfaces page actually shows you all of the interfaces that are available on this device. And this page really serves as a first step, initial networking configuration. And it's really mostly recommended to use configuration in this case, in case nothing is, or no IP is defined via DHCP, and instead you use static IP addressing, or you have to use PPPoE, because for PPPoE, you have to actually, it's a chicken and the egg situation. You first have to have internet in order to access flexiManage. So you have to configure PPPoE. And this is what you can configure PPPoE by clicking here and enter all the resources, enter all the information, and it will connect. But otherwise, in cases like these, where the default port, and this is using our image, the first port is always configured as DHCP, and this device already has internet access, and it even shows that link status is up. And actually, if you go to troubleshoot, actually advanced, or under settings, troubleshoot. Yeah, connect. If you go to troubleshoot and connectivity, you can actually see that this device indeed does. We have these built-in monitors. You can see that this device actually has internet access. So there's nothing needed here anymore. And why I mentioned this is, well, the way it works is this is just initial configuration. Device configuration, actual interfaces configuration must be done via flexiManage. So if everything is already has internet, just switch to the next step, which is to add the token. And after that, you will complete the configuration of the interfaces through flexiManage. It's really important to always complete and configure all the interfaces through flexiManage and not locally or not combine, because the flexiManage configuration will overwrite the local configuration. So keep that in mind. Okay, so let's use the Acme token for branch devices. So go back here, we copy the token, paste it, click update the token, yes. And in a few moments, the device should show up as waiting for approval. At least it should. Luckily, I also have access to this device, so I can check what's going on real quickly. But usually, because this device has LTE, it requires a little more time for it to. Yes. So this. Okay, another troubleshooting session incoming. So I have a console session to this device, and one of the common issues that we see is that you get a response from server that device already exists, even though it's not on my account. So this is because in some cases, vendors, we rely on UUID to actually identify devices and a couple of other things. And when you run system checker, it will say that everything is passed, except the UUID. The UUID is not legal. So in some cases, where the vendors use same UUID on all of their devices, you will be presented with this problem where this device cannot register because the UUID is identical. It's already been registered with some other device. So you have to generate your own UUID. And to do that, there's a need website. You can just use the first one, UUID generate. And I believe it's, yeah, online UUID generator. And we'll work to make this a lot easier in future. But basically, you have to generate UUID version 4, and then go back to the console and edit the FW agent config YAML file. And yeah, this device already has a UUID. I think because I use this device for something else, and this is probably the reason why. So it's my self-inflicted issue problem. So I'll just paste this UUID, and then we'll. This is how we basically edit the UUID of the device, and in a few moments, hopefully, it should connect. Yeah, it's building interfaces. Bingo. So this means that it's now not approved. And if I click here, we have the device ready. So let's approve it. This is going to be branch 1 device. And you don't have to put the description if you don't want to. And because this is an LTE device, we usually recommend that you first approve device, wait for it to complete the first configuration session, connect to show the vRouter and not running state, and then complete the actual interfaces configuration. In a few moments, yeah, that's it. We can go here, and if you go here to interfaces, now we see this device ready, and we can start configuration of the interfaces. So this device will actually have several WANs. It will have dual WAN, primary and secondary. So the primary WAN is already accepted via DHCP, and the secondary WAN is going to be an LTE. And to do that, all you have to do is you have to click enable, and it should recognize everything in advance, and you click save. Now we have dual WANs configured, but not yet running the device. So for LTE, actually, for LTE to work, the device has to start. And we'll configure one of the networks as one of the interfaces as a LAN. In this case, it's going to be this one. And let's just use non-conflicting IP, which should be 35. This device also supports Wi-Fi, but I'm not going to use it in this case. So I'm going to click update. And let's wait for it to sync. Usually device disconnects for a moment briefly and then reconnects. And you can actually monitor the console situation right away. It actually reconnects and connects back. You can see here how it's fetching the LTE information. Here in a few moments, I'll click refresh. It's going to start to show that it's connected. Go. This is the last log. Here we go. Now we can start this device. So now our network is slowly growing. We have first branch ready, and we have DCs ready. So let's add quickly and fast other 3 branches. All 3 branches are actually going to be on HeadSnap. So just to quickly simulate them. And let's just do console installation, and it's going to be faster than the UI. So first thing that we want to do is, this is the first device. We want to add the repository, and then we want to install. And why wait? Yeah, while this is installing, let's switch to second one, HZ02. Let's add repository. And let's also add repository to third one. So I have them all in tabs. So while this one is installing, we're also going to do installation at the same time on the other devices. This is how, in most cases, administrator looks like. Sometimes for smaller deployments, it's always repetitive. So yeah, this is the primary. Okay, so this one is ready, and let's run the system checker. We'll just use a configure system silently and double check. That's it. Because this is Hetzner, we have to make sure that NetPlan matches the interfaces. And this is well documented. We actually have Hetzner documentation here. And if I do fconfig, WAN is actually ETH0. So if I do nano, just change this default interface file, which they just paste. That's it. Let's go here. And by the way, I can see the branch one is running already. So let's go here to tokens, and let's start adding this token to the other devices. See, agent token. See how fast actually this is, to see how much faster it is to actually add devices using the branch 2, using the command line, but you can use the web UI. The web UI is also good for troubleshooting purposes. Like if you have some personnel on site, tell them log in locally and do some basic troubleshooting. Of course, similar can be done also via SSH. So yeah, this is it. This device is also ready. Make sure that, because this is a VPS, WAN is DHCP, click update device. And let's click run. So we have now branch 1, branch 2 ready. This one is ready. So let's go to the secondary branch. No, actually third branch in this case. Actually, I accidentally ran it manually. So let's configure system silently. Check system configuration fast. That's it. Same procedure. I have config to make sure that ETH0 is the interface name, and then go to NetPlan, grab the first file, the only file at the moment, and ETH0. Go. Okay, added. This device is ready. Let's quickly also complete this one. So we quickly can complete the configuration from the UI. Good. And you'll notice that I use the same token for all 3 devices actually. And for some, yeah, okay, so one HD, okay, so we have this branch 1. Okay, so all branches are here. So 2, now this is going to be branch 3, right? Yeah, no, yeah, yes, branch 1, branch 2, branch 3. I have to prove it. 4. So this is how it works, how it looks when you actually work a lot with flexiWAN. You get a lot fast. So yeah, but here we have, there we have it. Now we have things almost ready. At least the devices are ready. And let's complete the interfaces. You just assign them, click update. Then let's go to find the last branch. Click update. And bingo. Let's start running the devices. So in a few moments, all of these devices will run. And I didn't add firewall rules, so I cannot access them via SSH at the moment, but that's fine. So great. So now the first the first part of our webinar, and this was actually fast. It only took us half an hour with all the talk to deploy that we deployed 6 sites. And if you go here under dashboards and network, we can actually see that we have 2 data centers and 4 branches. One is dual WAN, and all the other 3 branches are single WAN. But that's not going to stop us from creating multiple tunnels between them and multiple tunnels to data centers. So now let's talk about tunnels and topologies. flexiWAN supports various tunnel topologies, starting from full mesh to hub and spoke, or some combination of those, or any kind of approach that you want. So what's possible right now, even in this case, is to start to connect tunnels between all of these branches, and even without just go here in the inventory, and I can say connect DC1 to branch 1, and other actions create tunnels, and it will connect. Or I can connect multiple devices like this, and I can select all branches and DC1, and then I can say create tunnel. And we can do full mesh, or we can do hub and spoke, and then I can say the DC1 is the hub and everything else is spoke. But this is not going to work for us in this case, because sure, for deployments that are really, really simple, this works fine. But what we want to do is we want to use a path selection, which is our application-based routing later. And to use that, we have to actually use path labels. So path labels are used with multiple features on flexiWAN. With multiple features in flexiWAN. They're used for tunnels, and they're also used for path selection. Because we can apply path selection to devices with specific path labels, and I'll show that later in this lesson. So to summarize, we have all devices ready now, and now we're going to go to tunnel deployment and planning. So what we're going to do is we're going to create a couple of path labels, and then we're going to use those path labels to connect sites. And if we open a diagram, you can actually see that I used ISP1 and ISP2 path labels. That's going to be applied to all of the branches. Then we'll also have branch path label, and then we'll also have DC path label. And I think there's also going to be one more path label for direct internet access, but we're not going to use it. And also for the dual WAN, we want dual WAN to connect to both DCs actually. So using both labels. But yeah, let's go on step by step. So let's first create path labels. We already have some path labels. This is my demo environment. So I have ISP1 and ISP2 path labels already ready. Let's also create a branch path label. And let's also create data center path label. So the data center path label will be used only for connectivity between data centers. So I think that's it. I think we have ISP1, ISP2, and we have branch and data center. So let's get started. So let's get started with data centers. The way it works is you have to configure interfaces. You go to interfaces page and you start to add path labels. So here is the data center path label. We click update. And we'll do one by one to make things a lot easier to understand. So DC1 and DC2. So if I was now to connect DC1 to DC2, nothing would happen because they don't match. The path labels can connect tunnels using only between, you can only connect tunnels using the same path labels. So let's go to DC2 and let's also add here data center. Okay, so now let's connect DC1 to DC2, create tunnels, pick the data center path label. Doesn't matter, it's full mesh or hub and spoke because it's just two devices. And now we can see the tunnel job is added, and in a few moments it will connect these tunnels. So you see the dotted line is already there. So we usually gather a little bit of statistics before we actually show it's connected. And yeah, now everything is connected. So if I go here, devices are connected. Data centers done. They have connectivity between them, so each data center can connect to each other. Okay, so now we want to connect first branch to data center 1 and data center 2. So how do we do that? We go to first branch and go to interfaces, and let's do it like this. So we have, what do we have? We have two WANs. So ISP1 and ISP2. And you click update. And now what we want to do is we want to connect branch 1 to DC1 and DC2. So what we want to do is we want to actually have both, we want branch 1 to connect to DC01 using its primary and secondary WAN. So for that to work, you actually have to assign both path labels to the data center WAN. And data center has a single WAN, but data centers have much higher uptime and availability, so this is not the problem. The branch devices require multiple WANs because they use usually, local internet, providers, and with different SLAs. With actually no, it's not a dedicated line, so there's completely, the completely different SLA than for dedicated line. So it's cheaper for you to just have multiple WANs. In this case, it's a wired one and the LTE. And this is how it looks. You configure primary and secondary ISP labels to the data center 1, and we do the same for the data center 2. 1. And go. So let's connect. Select branch 1, select data center 1, click actions, create tunnels. What we want? We want to have two tunnels between the branch 1 and data center 1. But we also want the same thing to the data center 02. So I unselect data center 1 and select the data center 2 and click create tunnels. Same thing. SP2. Tunnel jobs. So let's go here to network. And this is now going to look much nicer. So we have here, well, now it looks nicer. So now we have here, you can see that we have two tunnels between branch 1 and data center, two tunnels between branch 1 and data center 2, and also a tunnel between data centers. So if we go here, you will see that all tunnels are connected. And for example, branch 1 is connected to DC1 already, but it's not connected yet to DC2 using LTE. So sometimes in LTE, with LTE, not all tunnels may connect right away. It takes a little bit more time, but it will connect. But at least the primary is working. So here, branch 1 is ready and connected to the data center. Okay, so let's use the same ISP labels to connect the other 3 branches to data centers. But here, if we go to primary, to the secondary branch, you'll see that actually it has a single WAN. No bother. So this can be a, some very, very remote store or branch with like 5 users, and they just have a single internet provider. Cool. But let's again assign both labels. And why? Because we want to connect. Actually, we don't have to, but it's easier it will be easier to identify. We want to connect each branch using data center and using hub and spoke topology, but quickly in a faster way. So let's go and so number 2 is done. Number 3, SP1, SP2, and let's go to the 4th branch. SP1. The reason why I'm assigning all of these at once is because I want to connect all of the tunnels at once, at least the primary. So we'll use these labels also. We'll reuse these labels to connect them to the branch, to connect branches to the tunnel, to in a hub and spoke topology to data centers. So what we'll do is, because the branch 1 is done, we'll select these 3 branches and data center 1, and then we'll go under actions, create tunnels, and we'll just pick ISP1, hub and spoke, DC. DC1 is hub and spoke. So we'll connect these 3 branches to the data center 1 using hub and spoke topology, and using ISP in hub and spoke topology using the ISP1 path level. Click create tunnels. That's it. And if you go here to network, now things are shaping up. You can see actually that the branches indeed are going to connect to the DC1. But while this is still happening, let's also go and select again all the branches that all 3 branches as previously, and also DC2. And now we'll use ISP2, hub and spoke, DC2, create tunnels. Same thing. We go here to network. Things are now looking a bit more complex, but nevertheless, starting to get while complex, it's starting to show the power of flexiWAN and ability. It shows you how to create advanced tunnel, topology, which offers huge redundancy, because now each branch is connected to each branch has at least a tunnel towards primary data center flexiWAN and to the secondary data center flexiWAN. So in case the network between in case DC2 goes down, DC1 will be up. And branch 1, which has dual WAN, actually has 2 tunnels using 2 ISPs to DC2 and to DC1. So it's even more redundant approach. So this really just shows, how easy and fast you can create these tunnels between flexiWAN sites in just a few clicks, and you get full redundancy. And here in tunnels page, I can actually see that we now already have a bunch of tunnels, and 1 tunnel is not connected. Branch 1, DC02, it's okay, because branch 1 has dual WAN anyway. Sometimes these, we use AI network healing to actually detect anomalies and issues with network. And in this case, most likely stun ports keep getting changed on the LTE, and this is indeed the WWWAN interface. So sometimes it requires a different stun port, and it keeps opening new ports, but it's not succeeding. So maybe it's flapping, maybe we'll see it in a few moments. Later, flexiWAN will actually recommend an action, and you will see a warning here, and then it will say, what do we recommend? In most cases, you just want to click sync device and it will reestablish the tunnel. But for now, yeah, oh, bingo, now it's connected. Actually, everything is connected. Perfect. So we already have 11 tunnels. So if you go here now to network, you can see that everything is very nicely connected now. And if we go to world map, actually, you can see that the branches are, connected neatly. Although I don't see why there is no data center branch, but maybe because it requires zooming in. And this is why. So what's basically happening here is that we use IP-based identification of where is what. So no, none of these actually, most of these are not connected. Correct. These data centers are actually in Germany, and the branches, some of them branches are in Germany, and others are scattered across the world. But it's okay. Let's keep it as is. But we can, as you see, if in case we don't detect it correctly, based on the geo IP information, you can drag them and actually then you can use the correct you can put the location to the correct location. So moving forward, now we have tunnels. Now we have device. So far we did clean installation. We built from scratch everything, all the sites, including 4 branches, 2 data centers. Then we added tunnels. We covered path labels, how to use path labels to connect, to use much more granular approach to connect when connecting tunnels. And we established tunnels between all of these sites. So next step is actually to start to do some traffic management, whether using firewall rules or using path selection. So let's get started. So I wanted to focus actually first on the path on the firewall. But before we do that, we want to also with flexiWAN, many features are used with other features. So in this case, path selection is going to be used for tunnels, but also with path labels are going to be used for tunnels, which offer a much more granular approach when creating tunnels. But in addition to using path labels with tunnels, you can also use path labels with path selection. And path selection relies on the traffic and app identifications, which is a built-in database of applications that are application signatures. And this database is used by path selection and also by firewall categories, by firewall. So you can use any of these categories to reject or allow specific traffic, or in case of path selection, you can use to route this kind of traffic. You can route this specific traffic through specific path labels. We're not going to do it. We're not going to do specific traffic. We'll route all traffic. But in this case, what I wanted to show here is we'll use firewall first to block BitTorrent, and I don't know, we'll find something to block. Some of the Netflix, or something that we don't want to route through the tunnel. But we'll create a policy, and then we'll install this policy on all devices. So let's get started. Let's go to security and firewall. And we already have a company policy, but let's create a new policy called branch. And here we'll just have a few outbound rules, and we'll switch here on the app. We'll just use traffic name. And I said Netflix. So we don't want to allow Netflix. We don't want, because again, we'll be routing all traffic through the tunnel from each of these branches. So we don't want end users to route higher bandwidth through the usage traffic through the tunnel. And we'll add a rule. Let's also add this is just an example, of course, but let's also add something else. Yeah, we said BitTorrent. We're going to deny it. And we could theoretically block the whole media. And in this case, if we go to traffic tag, then you can block like complete category. And for example, what you can do is, you can say, hey, I want to block remote access also. This is to, prevent the LAN clients on the branches from using, TeamViewer or, remote tools to access, which could be corporate violation, for example. So, okay, this is enough. In this case, this branch policy is blocking several types of traffics based on traffic and app identifications database. But let's allow something. I still want to be able to allow SSH. So I want to be able to at least access these branches WAN IPs using SSH. And I'll click add. And we'll save the policy. Okay, so now we have branch policy. And branch policy, the purpose of this is to actually show you how easy it is to define firewall rules on a large scale with flexiWAN. So here we have, 4 branch devices. So we'll go 1, 2, 3, 4, select them. And in a similar fashion, like creating tunnels, we'll just go here, install policy, and under firewall, we'll select branch policy. Click install. That's it. Policies are now added and are being installed. And each change that you make is actually sent as a job. And you can see that all of these devices have these pending running jobs now. And in a few moments, it will be in a synced state. Some take longer, some take less. Usually the physical device will, because it has more interface. Yeah, it's actually fast. So already there. So yeah, it's so imagine in a traditional networking devices, with traditional devices, how we would have to manually configure each firewall rules per each device. It shows you the power of flexiWAN. But if that's not enough, because every device is not the same, you can also do device-specific rule for each of these devices. So you can add additional firewall rules, such as one-to-one NAT or port forwarding. Then you can combine global rules and device-specific rules. So, okay, now we have firewall rules in place between branches. So these 4 branches are not going to be, which are now connected to data centers, are not going to be able to connect to the resources what we defined. Oh, of course, I forgot. I forgot to actually complicate things a little bit more. So I said that we are going to have 2 tunnels between each of the data center and branches. So in case one data center goes down, the second data center will pick up the traffic. But here and these are hub and spoke topologies, what we just did. But I forgot to add basically is that we also want to have full mesh between these 2, 3, 4 branches. And this just additionally helps all of these branches to communicate in case one of them cannot use their internet, because they're single internet providers. In case one of the branches cannot use the access data centers because of the upstream issue, some other branch can, then they can route traffic through them. So let's create additional that label. And yeah, no, actually we created it, which is the branch. So we all that's left, we're going to assign it. So in this case, we'll just use the more stable link for the branch 1. So we'll use branch and go here, and let's go to branch 2. This one has a single WAN. So it's less likely that the branch 1 with dual WAN will have internet issues, but it's more likely that the branch 2, because of the single WAN, may not be able to reach data centers or some outage in between in the upstream, but that it can reach the nearest branch to it. So that's the plan. Okay. So now let's connect all of these 4 branches in full mesh topology using the branch label. Bingo. And actually, hold on, did I make, so this one, the branch 1. Yes, it's branch 2. I used the wrong label. It's not peering, it's branch. Branch 3, branch, and branch 4. Branch. Okay, never mind. I'll just reselect them. And then, even though I've already added some, let's just add a few more. Branch, good. Some tunnels already exist, which is fine. If you go here to network, now we see full power of this product, the idea basically is, now we have, even though it looks, a bit more complex now to see, but what we see here is that, all of these branches have full mesh between them, and then all of these branches are connected in a hub and spoke topology to data centers. And in addition to that, both data centers are redundant, they're connected to each other. So that's a lot of tunnels. You get here, we have now 17 tunnels, and all of them are already connected. So if you go here, I usually put it like this to make it easier. And yeah, you may have noticed that, all of this is easy to manipulate. Now we have these branches fully connected in a fully redundant fashion, utilizing multiple tunnel topologies. And now, to move one step forward, Firewall is also installed on each of these branches, and it's firewalling. And what's next is to say that we want to route all traffic to create a path selection policy, to say that we want to route all traffic from branches to data center, through data centers. And the way it's going to work is, we're going to create a single policy. And what we want to do is we'll actually create a policy which will fail over traffic, tunnel traffic from each branch through between. We can do even load balancing, but I prefer in this demo to show failover of the using ISP1 and ISP2 links. So meaning that each of the branches will failover traffic will route all traffic through the tunnels, and in case primary tunnel goes down because the primary DC went down, it will fail over using the secondary tunnel, which is connected to the DC. So to do that, we just go to path selection, and let's create another policy called branch routing. And we're not going to do it very complex. We'll just use the default rule, which is by default disabled. But the idea is that it doesn't use any kind of traffic, that it grabs all traffic, and that it routes all traffic across the path labels that we define it. So all you have to do is click edit, status, enable, and then you have to say ISP1 and ISP2. And in this case, priority is selected by default. So it is going to route all traffic through primary ISP, meaning primary label, which is actually in this case data center 1. And in case data center 1 is unavailable, it will route through the secondary. Click update, click save. And then now here on the devices, we select these 4 devices. And then their actions, we click install policy. Path selection, you change it, of course, the policy from the to firewall to path selection, and branch routing, click install. Okay. So now let's cover a little bit, because it's been over an hour now. Let's cover what we did. So we built all of these sites from scratch, and then we configured the interfaces. Then we talked a little bit about path labels, explained the purpose of path labels, assigned path labels, then interconnected all the sites in between them in multiple tunnel topologies and multiple redundant tunnel topologies. And finally, then we defined firewall rules for multiple of them and employed them at the same time. And then the same thing we did for traffic routing. So now we defined path selection, where we basically route all traffic through data centers in a fully redundant fashion. So all the branches have two tunnels. Each branch has a tunnel to primary and secondary data center. So if primary tunnel fails, the traffic will still be routed to the secondary data center. And this is the end result. This is how it looks. And these are the data centers in the middle, and these are the branches. And if that's not enough, the branches are also interconnected between themselves. Maybe overkill, but we're trying to demonstrate the full power and show how easy it is. I mean, look, I built a whole network in an hour, basically. So that's really shows how easy flexiWAN is, easy to use. So the next step is, and I hope that we'll have time, is peering. So we had a demonstration previously about peering, and I'm not sure if it's going to end up working if it doesn't work, it doesn't matter, but we'll try. So what we have here is 2 data centers, which is basically 2 flexiWANs in the data center. But what's possible also is that there is a third site, the third site that can be in a physical location, and this site has third-party router, third-party network device. In this case, we'll use PFSense under open source product, but not an SD-WAN. So to connect to it, it's a bit different. It will require a little bit more work, but nevertheless, it's still possible to connect to third-party devices. And what we'll do is we will connect using IPv2 and IPsec. So as long as your third-party networking product has this supports IPsec and IPv2, you theoretically should be able to establish tunnels from flexiWAN to it. And of course, it's not an SD-WAN product, so a lot of things have to be done manually, but you should be able to do that. And let's give it a shot. I can't promise it will work in this case, but let's at least give it a quick shot. So we have peers. You go here to the peering page and click new peer. And in this case, we'll call it FW0 on site A, doesn't matter. So site A, it's some site 3, third site, which has this firewall. And in this case, we'll use ID type of the FQDN for identification, not an IP address. So local ID, this is not typical IPsec configuration. We'll use for local IP flexiWAN. Of course, don't use such easy names, but and for remote ID, we'll use remote. And for pre-shared key, we'll just use some random string or something that I will flexiWAN plus. And remote IP will be actually the IP of the remote network device, third-party network device, which is this. So because we're just starting now, we'll keep the peer monitoring and everything here as default. We'll just use these parameters, and the remote device will use these also by default. So just click save. But the prerequisite to this is to also create a path label for peering. In this case, there is already one. And then we'll use this peer actually to connect, to use this path label to connect the data center to the third-party device. So let's quickly switch to the third-party product, which is a pfSense in this case. And here we have single WAN device, and it's running also, it has a public IP on WAN, and this is exactly what we need to connect one of the data centers to it, or both, but we'll just use one data center. Okay, so let's get started. If I remember correctly, we have to go here under VPN and IPsec. And remember, you have to define everything manually, just as we did on flexiWAN. Okay, this is an extra window, we don't need it. So here in the peers, we have, this is the configuration. And because we'll use the data center one, we'll use this IP for phase one in pfSense. So let's add phase one. flexiWAN, IP2, WAN interface, remote gateway is this one, and the authentication name, identification will be mutual PSK, pre-shared key, and we want to switch the fully qualified domain name, and you want to basically match both ends. So in this case, your local ID is going to be remote ID, peer identifier, and the remote ID will be remote ID will my identifier in this case a pfSense identifier is remote, and fully qualified domain name identifier is this. So you just do this, and all you have to do is change it to 256 bits here in the encryption algorithm, and the rest of the things should be kept as default, hopefully. But I'm not going to click apply changes. Let's add phase two, where you actually define networking. So very important thing is you want to use routed VTI in this case for configuration for phase two. This is the only way you'll get flexiWAN routing working, and you'll get routing working between flexiWAN and pfSense. So in this case, you just select routed VTI. And for local address, this is just you just have to have this loopback IP, so it can be anything as long as it's not used, and it's going to be in this case 3.1 and 3.11, and all we'll have to support here is 256 AES, and the rest of it, just make sure, yeah, that's it. Basically, the rest of it, that's it. We will also configure it because we're doing it here on the, we're going to install it on DC1. We'll use this IP as a ping IP, automatically ping host, save. Valid network IP. Did I mess up something? Yes, of course I have. So valid network, remove network. Yeah, of course. Okay, save, and that's it. apply changes. So on pfSense side, this should be done by now, at least the initial configuration, without the routing part. And here on the peers, it should also be configured. So if we go here to pfSense, in status and interfaces, you'll see that it's trying to connect, but it cannot connect to anything because there is no configuration, no IPsec installed, or no peer installed for any of these devices. So what we'll do is we'll select here, and from action button where everything happens, we click create peer connection. We select peering path label, and we select the peer that we just created, which is called site 3. And of course, it doesn't work because I didn't assign the peering path label. So yeah, just click assign. And here on the DC1, select DC1. We are going to click create peering connection, peering site 3, DC1. That's it. Now the peer job is added, and this is it. But this is we're just getting started actually. Here we go. Now it's established already. Bingo. Disregard the first one. This is just a UI issue in pfSense. The second one, this is it. So this is the correct one. But and actually, if there is a command here on flexiWAN, which you can do is also to make sure that it's connected, because here it should probably show that it's all connected. Yeah, it is. DC1 is connected to site 3, but this is just pure IPsec. You don't really. So you can actually first. Let me just complete the first thing that I wanted to say. This is how it looks. When you enter this command, it actually confirms that it's established, that authenticated. But there's no routing between these two sites. They cannot reach each other. And actually, if you go here and if you filter by peer, I think it's if you let's find it. Yeah, at the bottom, if you filter, you can see that there is 0 drop and 0. Basically, these are not valid values, and this is because the devices still cannot talk to each other, at least LAN sites. So we have to configure that. And again, because pfSense is not SD-WAN, you will have to do it. And because it's not another flexiWAN, you'll have to do things manually. If you want to do, you saw how easy it is to connect flexiWAN to flexiWAN with third-party products. There was some added work required to get everything working in regards to routing tables. So let's do that actually. The next step is to go here. And in pfSense part, because we used routed VTI, we want to add, there's a new port that's available, IPsec routed VTI, and we want to add it. And then we want to enable it. No other flexiWAN, no other configuration is needed. We just click save and apply. But we also, to make things easier, we want to add firewall rules. Here under IPsec, we want to allow everything. In this case, I'll just to make things easier, you can have a more restrictive network, but this is a live lesson, so let's not complicate things. So now if you go here, we can see that flexiWAN interface is available, and that we have an IP. This is the IP loopback IP that we have defined. However, that's not it. This is not yet fully complete. What we have to do is, in order to reach flexiWAN data center, you have to add 2 static routes on pfSense side. One static route is to this IP range, but before that, there's also a tunnel loopback which we use, and this is in this case is 10.100.0.0 or 38 in this case, but we'll just use 10.100.0.0. So go to routing, and under static routes, let's add first 10.100.0/24. Sure, let's not typing it, but let's select it manually and make sure to pick the correct gateway, flexiWAN 10.100.0.0. And let's also add another, which is this one, the actual LAN IP. Again, same thing, save. Okay, so now the static routes are added, and let's try to ping. Let's see what happens. So let's try to ping this IP. Diagnostics. Ping. I theoretically think it should work by default from the default source. Let's try this. No, it's not gonna work. Let's try to ping via IPsec interface, but I don't think it's gonna work. And here's why: because we haven't defined a static route on the flexiWAN side, because you still also have to do it on the flexiWAN side. But let's be quick. Let's just quickly try. This may work on the direct interface. No, it's not gonna work. No. So what we have to do is we have to go here and let's wait for this ping to time out. Okay, and here the LAN network is actually 65. So we have to actually add this static route. So we have to add a route destination using the peering interface, and I'll just add metric 0 just to be sure, and I'll click add static route, update. And theoretically, now from this device, I should be able to ping a pfSense line. And let's try it. You only want to send 3 pings. Bingo. So that's it. The peer is now connected, and we have communication between these 2 sites. And if we go here, now there's an added element, an added site on this deployment, on this diagram. So we now have 3 sites. We have 4 branches connected to both data centers. And also data center 1 is connected to site 3. I could also connect data center 2, but I don't want to complicate things for this demo. But the idea is that now we have all of these sites can also access resources on a third-party network device, behind the third-party network device. So this peering functionality is really great to integrate flexiWAN within an existing network, or to combine it with an existing network. So yeah, that's it. So far we have covered built from scratch DCs and sites, configured DCs, explained the importance of path labels, assigned path labels, created tunnels between all of these sites. Then we have created firewall policy and path selection policy, peering, and now let's finalize it all with just a quick demonstration of of remote worker options, which is our first application from the App Store. And what we already have it installed here. Basically, this is how it looks. You can configure remote worker VPN configuration service for remote users that don't sit behind flexiWAN, that they work from home or from remote offices. And then from their laptop, they can actually reach the nearest branch or nearest DC and access internal resources this way. In this case, we'll just create this create this remote worker VPN only for data centers. So we'll install it in data centers because they have higher availability higher up there. So as this was used on previous webinar, I'll just keep all the settings here by default. What I will not do is route all traffic via VPN, and we'll just use we'll configure to have actually just Google authentication for flexiWAN in this case, and I'll click Save Configuration. And if I go here, I will select both data centers, and we're going to install the application called Remote VPN. And we need to find a non-conflicting IP, which I think is 99.100 to restart, and 3 devices. So yeah, our remote worker actually uses OpenVPN in this case. So in addition to IPsec, we also use OpenVPN, and I'll click Save. But that's it. Basically, now now it's going to install to all of these to both of these data centers. And now all that's left to do is for remote users to actually access our portal using this Academy workspace, and you can sign in using Google. And then from there, whether they're using Mac or Windows, they will be able to actually use to remotely connect using our client. I'm not going to demonstrate that. There's a video separate session on that. But that's it. Basically, with installing of the remote VPN, this now is a complete network is full network is done. It's ready, and we have covered basically everything. You know, with this, we have covered everything and everything that we could, and we went through all of the lessons that we had, you know, all the previous 10 lessons. So yeah, I think it's time to wrap up. I hope this was enjoyable. I hope that you learned a lot, and that you saw how easy it is to use flexiWAN to build the networks from scratch in about less than an hour and a half. So yeah, thank you for attending, and hope to see you next time. Thanks.